Hello students, this is second part of the application of a straight line in physics. In the previous lecture, in the last part of the lecture, I have given you a question and that was based on what we have learned in the previous lecture. The question was related to graph between position x versus t, and this was the nature of graph that was given to you. Now we have to find whether the motion is uniform or not, and if it is non-uniform, whether the velocity is continuously increasing or decreasing. Now, again, as we have learned in the previous lecture, if I draw a slope here, let us say this angle is alpha. Again, if I draw a line here, tangent here, the angle is beta. Again, if I draw a tangent here, the angle, let us say, is gamma. We can see that as we are moving from point P to Q to R, the angle, that is the slope of tangent at a given point, is continuously decreasing. That is, alpha is greater than beta, and if at this point angle is gamma, I can say the beta angle is greater than gamma. So on the basis of what we have learned, we can say that the slope of the tangent, that is tan alpha, is greater than tan beta, and we can say tan beta is greater than tan gamma. So the slope is continuously decreasing. And what does slope represent here? As we have learned, slope represents rate of change of velocity. And this you have already learned in the previous lecture, and if you have not gone through that lecture, the link is given here. You can just go through that lecture again. So this velocity here is continuously decreasing. It means the motion is non-uniform. So as time is increasing, velocity continuously decreasing, and hence we can say that this is another example of non-uniform motion. One example is already discussed in the previous lecture.
So that was an acceleration, this is a deceleration.
In that case, the position velocity is continuously decreasing, means the acceleration is negative or retardation we can say, and in that case the acceleration was positive in that case. Now, I am again coming to some other concepts which we can easily learn with the help of what we have learned about straight line. So the another thing is similar to what we have learned here. If a graph is given between velocity versus time, then I am not going in detail of this, but you can simply say that the slope, that is tan of this angle, let us angle is theta, then this tan theta will give us slope of velocity versus time graph. And again, we have already discussed what is velocity versus time will give us. So the slope m, which is equal to change in velocity versus change in time, that is dv by dt, and this gives us acceleration of a particle. So as we can see here, in this case the acceleration is positive and it remains constant. So we can say that particle is moving with a constant acceleration. Similarly, we can say that in this case, velocity versus time graph, we can say that acceleration is 0. And in this case, we can say that the acceleration in this case is negative, and you can verify these things on the basis of what we have learned in the previous lecture.
So basically in previous graphs we were drawing the graph between displacement and time.
Position versus time graph.
Position versus
so
time.
There the slope was velocity, and here it is velocity versus time graph. The slope is acceleration. So here acceleration is 0, means velocity is constant, or this is example of uniform motion. Here in these two cases, velocity is continuously changing. Changing means it can either increase or decrease. So in this cases, the velocity is changing, means the equation is non-linear motion or non-linear velocity is given here. Now there are various other parts where you can apply the concept of straight line. And one such case is, you all know that rate of change of momentum, that is delta P upon delta T, will give us force. So force can be of two types. One can be the average force and one can be instantaneous force. So let us say a graph between momentum, that is P, which is equal to m into v, versus time is given to us, and I have to calculate the value of average force. So a graph is given like this. I have to calculate average force, let us say between point A and point B, and the coordinate of point A and point B is given. Let us say momentum at this point is P at a time, let us say T naught. Momentum at point B is given as 2P and time here is given as 2T naught. And we have to calculate the value of average force. Can we calculate this with the help of a straight line? I am giving you a few seconds to thought on this, and then we will discuss the solution of this part. So pause this video, start doing this. If you are not able to do this, we will discuss after a pause. So now you must have tried this. If you have already gone to the solution, it is good. Otherwise, you just go through the remaining part of this video, and Subbu sir will let you know how we can calculate average force in this case.
So basically, as everything is written over here, force is change in momentum by change in time. You can apply this thing, or let us suppose we have studied straight lines. So if we join this A to B, we'll get a line, or we can also say that AB is a chord of this curve. So this chord of this curve AB will have some angle with x-axis when it will be proceeded backward. So that angle would be basically something like this. When proceeded backward, that is also theta. So if you talk about delta P by delta T, so what is delta P by delta T actually? This portion, this height is delta P. That is the change in momentum of the body while traveling from point A to point B. And which is the change in time? So this horizontal line is the change in time of the body while traveling from point A to point B. So the ratio of this height by this base will give you the force. That is actually also the slope of this. So this is what it is written over here. Now let us find the force here. So the force is delta P. So final momentum minus initial momentum divided by delta T, final time minus initial time. So what do we get? P upon T naught. So this is the force which has led this change in the state of the body. So
again, coming to some other portion of the physics, like you must have studied electricity, some basic part of electricity like Ohm's law. So in Ohm's law, you have learned the relation between potential difference and current flowing in a circuit. The relation is very simple. The relation is V is equal to IR. Now if I want to plot the graph of this equation, will it be a straight line or some other equation? As you have learned in the previous lecture, and if you have not gone through the previous lecture, the link is given here. Just go through the basic form of a straight line. One of the most basic form is y is equal to m into x plus c, where power of both x and y is 1. This is the equation of straight line. If I compare this equation with the equation of Ohm's law, I can see that c is 0 here, but if it is written as y and it is written as x, then we can say that between v and I, the graph is simply a straight line. And what is r here? So r representing the value of m, that is slope of the straight line. So if I plot a graph between potential difference and current, then the resistance will be the slope of the graph, and the graph will be a straight line. Since c is 0, it is passing through origin. Let us say two such graphs are given. This is graph number 1, this is graph number 2 at some different temperatures. So can I say anything about the resistance in graph 1 and resistance in graph 2? Now we can simply see that this angle alpha, let us say, and this angle is beta, then beta is greater than alpha. This means that tan beta is greater than tan alpha. Now you already have learned in the previous lectures what is tan alpha and tan beta. These are the slope of the straight line. So I can say that the slope of this line, that is 2, that is the resistance of this graph, R2 is greater than R1. So just by learning the basic concept of a straight line, I can say that the resistance in this case is greater than this case. This is one of the favorite questions which is frequently being asked, especially in the 10th class board exams. The exam is very near. You can just learn this concept, and I hope that you will be benefited in the exam here.
One thing which is in a very normal language, if we try to understand what is resistance, something resisting the flow of current. So if you see here, there is a change in the current, the amount of current, that is delta I. And if you, from this point, this is the origin, if you take a perpendicular here, so what will you observe that for this delta I, the first graph has to apply a potential this much, a smaller potential, and this graph has to apply a bigger potential. So this graph is actually working more in order to pass the same current. So because the resistance is high, more the resistance, rho, more power is required, more energy is required. As in normal situation, you also see if there is more resistance, you will apply more force. Similarly,
Yeah, basically, potential difference in current scenario is simply acting as the force which we applied in the during the motion. So potential difference is force, and this is like displacement. So to displace a body by the same amount, we have to apply more force. Means the body is more resistive towards the state of change of its motion, which is similar to Newton's law. So you can say that the equation of Newton's second law and Ohm's law is similar. Just you have to see the things slightly differently. The potential difference here represent force, and this I represent, in that case, acceleration. Here it is I, and R is similar to mass. So mass, you know, is inertia. That is ability of a body to resist in the change of state of motion. Similarly, resistance here is a property of a body which try to resist the flow of current through the body. So I hope you must have learned some interesting concept in this lecture. In the next lecture, I will again come with a few more application of a straight line, some other form of a straight line, and then till then you can learn this concept, revise this concept, and then you will complete the application of a straight line in the next lecture. So thank you for attending this lecture, all the students. Thank you very much.